Number 25 says, how fast is the volume of a box changing? If the width is increasing at 3, length is increasing at a rate of 2, and height is decreasing at a rate of 1. When h equals 4, w equals t, and volume equals 40. Okay, so we want how fast the volume is changing, so dv dt. We have dw dt, dl dt, dh dt. So when h equals 4, w equals 2, and v equals 40. Okay, so the first thing we want to do is use our volume, length times width times height, and dv dt is equal to, I guess this is dl dt. Oh gosh, so guess what? We have to do a three-way product rule. Okay, so here's how we remember. Gosh, I can't remember the last time we did one of these. Probably the first time I showed you. Okay. I mean, it's not the first time, but that was the only other time. They don't show up very much. So we have take the derivative first. That's dl, I can't write, dl dt. I'm just checking my clock. I gotta watch what I'm doing. Okay, dl dt times wh plus... that was the derivative of the first times the second, and the third, and then it would be L and dw dt times the first and the third h plus lw dh dt. So I mean, it's a pretty easy problem, but that's how you differentiate those. So we have w and h, but we don't have l. But so we've differentiated it, but we have the volume after the when, so we can figure out what L is. So volume is, so let's just do it. Let me get this a different color. So we'll say 40 equals 4 times 2 times length, so 40 over 8 equals the length, so the length equals 5. So now let's substitute back in. We want dv dt. We know dl dt is 2, and the width at the time is 2, and the height we know is 4, plus L, which we found out was 5, dw dt is 3, and h is 4, plus L, which was 5, and W, I'm trying not to get confused, 2, and dh dt is -1. So let's see what we got. We have 16 plus 60, that's 15 times 4, right? 60 minus 10. So I get 66. Let's see if that was what I got. Yay! Centimeters cubed per second. Okay, that's how you do number 25, and there's your homework.